forgotten to save, but it's pretty evident that it's cleaning up the noise. Great. So now we covered how to enable scattering and how to enable individual lights to be affected by the fog. So let's turn off the top light. So we're back to just our light bulb scattering, and now I wanted to talk about phase as well. So what I'm going to do is, under a geo section, I have a light blocker geo. I'm going to turn that on and hide our ground, which basically just gives me a sphere around our light bulb, and it has tiny holes in the shader. So if you go on the overall settings, in the opacity tab, we have a noise with lots of holes, and that's basically what's giving me this effect. Now to see some of the rays coming through the holes, which is the effect that I'm looking for, I need to increase the intensity of this light. So I'll just go back to my light bulb and increase this value. I'm starting to see the rays coming through these holes, and I'll just do a bucket render over here so we can see a bit more detail. Great. So this is how you can do volume rays or good rays coming through a window and so on. Please note that the smaller your light is, the more intense this effect is going to be. The next thing we are going to cover is phase. So if I just do a bucket render around this section with phase 0, you'll notice how we see the rays coming towards the camera and some are going away from the camera and so on. Phase allows us to control which the rays coming towards the camera or going away from the camera. For example, if I increase this to, or decrease this, sorry, to minus 0.5, do another render and save, you'll notice that rays that are traveling away from the camera and not towards the camera are more visible. And here is a comparison. Save this one and now increase phase to 0.5 and do another bucket render. And you'll notice now the rays that are coming towards the camera are more visible, and rays that are going away are less visible. So again, this is phase minus 0.5, rays are going away, and rays 0.5, the rays are coming, or phase 0.5, the rays are coming towards the camera, and this one was 0. Now that we have phase covered, let's turn this back to 0, and I'm just quickly going to cover fog and hide fog. So let's hide our light blocker and bring back our ground, and also turn back the intensity of our light to default where it was. Under the fog section, we can enable hide fog. If you go to the emission color and change that to be green, you'll notice how we have a green fog appearing around 5 world units in our scene, as hide fog is set to be 5 units. You can check to make sure that we are at 5 units, my units, by checking our viewport. I have a measurement tool which shows that from the bottom of the grid to the light bulb it's around 11 units. So if I open the viewport again, the IPR, and I just change the height to be 7 units, you'll see how the fog moves upwards. You can also create a wall of fog, for example, by using the ground normals. If I change the ground normal, instead of pointing up in the Y, if I change that to be 1 in the Z, and I'll just reduce the height to something like 1. I'll also increase the attenuation of my fog to something like 0.5, or I can go to 0.1, just so it's easier to see the fog. We can also combine this with an overall color for our fog. For example, if I wanted to have a general red fog as well as a green wall of fog, it's easily achievable by using the general tint and the fog emission color. You can also control the ray contribution scale. So for example, if I didn't want this pink top fog to affect my refractions, I can just turn it down, and you'll notice if I save this one and then turn it back up, there's obviously a big difference the way the ray contribution affects our final render. Let's go back to one-on-one. Turn our fog back to white. And this concludes our Redshift volume scattering tutorial for beginners. Thanks for watching, and I'll see you in the next tutorial.
In this tutorial we're going to take a look at how we can use bump and normal maps in Redshift. It's fairly simple, but can be used to create very complicated and interesting shading networks. Redshift supports both bump and normal mapping technologies. These maps don't affect geometric detail like displacement maps, but simply affect lighting detail along the surface based on the UV coordinates. From a bump map, Redshift computes new surface normals, whereas normal maps already contain pre-computed surface normals. Because normal maps contain pre-computed normals, they can be cheaper to render than bump maps and can produce smoother results. Bump maps, however, contain height field information and are very easy to use because they don't require any special pre-processing. This is the scene we are going to work on today. These oranges are what we'll be focusing on. At the moment they are completely smooth, and we'll use bump and normal maps to try and make the surface more interesting. Let's do an IPR rendering to see how they look without bump mapping. As you can see, it doesn't look that realistic, more like smooth plastic. I'll render an area since we only want to be focusing on the oranges. Now let's open up the Hypershade window and start adding our bump mapping. Expand the orange material so we can see what we are working on. Right now the only thing that it uses is a color map. To create a normal map node, go to the Redshift tab and find a normal map node. Right-click the folder button and select the normal map file. Connect the normal map node to the bump input in the orange material. Now you can see that we get bumps in the surface. Not quite the way I want it to be, so I'll change the texture repeats to 7. The normal is not visible enough, so I'll boost the scale normal to a higher value. Starting to look pretty good. The small bumps really breaks up the glossy area, giving it a more realistic look. When handling normals generating using other software, you need to be aware of one thing. The y-axis of the normal map might be inverted. This can easily be fixed by activating the flip normal y option. Sometimes it can be hard to notice, so try both if you aren't sure which one is correct in your case. In Photoshop you can see how inverting the green channel does the same thing basically. Let's move on to adding our bump map using a noise that is a standard Maya node. Redshift supports many of Maya's nodes, including the noise texture. We want some larger bumps on our surface, so the orange doesn't look so smooth and even. First of all, let's add a bump blender, so we can combine a normal and a bump map together. The bump blender consists of 4 inputs and blend weights. The blend weight is basically the opacity of the overlay, where 1 is 100% visible and 0 is 0% visible. The blend weight can be driven by an image. It can be used for many purposes, but I'd say it's mainly used to combine bumps and normals together, to be used in one bump material slot. Add the normal node to the base input and replace the normal node with the bump blender. Right now we won't see any difference as there is nothing to blend with. Now create a bump map node from the Redshift tab. I'll set the height scale to a higher value so you can see the effect better when we apply it. Now create a standard noise. I'll set the repeat UV to 0.7 so we get larger bumps. Drop the noise texture on the bump map input and add a bump map to layer 0 bump input in the bump blender. Set the node to additive mode and then blend weight to 1. That's way too much, but could be nice if we were going for rotten fruit or something like that. I'll lower the bump height a bit to get more subtle result. A common confusion when using Redshift is the difference with applying your bump to the material slot versus the shading group slot. When you use the material slot, the bump map will be blended or layered along with the rest of the material when using material blending. This obviously only matters if you're using material blending. If you're using material blending and do not want this behavior, you can use the shading group slot instead. I'd say that your safest bet in the beginning is to use the material slot. Now I'll do a bucket rendering and we'll compare the bumped material with the smooth material. Hope you enjoyed this video and thanks for watching.
Hello everyone, welcome to this tutorial about compositing Redshift AOVs in Blackmagic Fusion. In this tutorial I'll be covering how to set up the AOVs we need to match the beauty. I'm gonna explain the difference between the normal and raw AOVs and how to create one from another with simple math. And we're gonna create some cool post effects like depth of field, motion blur, volumes and relighting. So buckle up, cause this is gonna be a lot of information. Alright, I've set up this simple scene, so let's see what we got here. We've got this cylinder with an animation on it to generate some motion vectors. We've got this refractive cube with a spotlight on it which emits caustics. This cone in the back has an emissive material on it, so it will act somewhat like a light. We've got this beautiful reflective donut and a sphere with some displacement on it, which will become visible in the render. And there's a spotlight on top which emits some nice volume light. And we've got these stacked cubes with some substrate